Okay, sorry for the delay. I tried to do this without an actual smartboard and it just wasn't quite working. So I had to wait until today so I could get back into school. Anyway, so this will be part one of quadratics. So the goal for this section is that we can graph a quadratic equation using the vertex, the axis of symmetry, the intercepts, and plugging in values. And then using the vertex and the intercepts, we're going to be able to solve some fun real-world problems. All right, so let's get started. So here is an equation, and then I graphed it. Y equals x squared minus 3x minus 4. So this ends up being a parabola, and I just wanted to show you a couple things. So some of the things that we're going to be deciding is, number one, whether it opens up or down. This parabola, as you can tell by the picture, it opens up, okay? So opening up means that I'm going to have a minimum value at my vertex. My x-intercepts. My x-intercepts, let's just show where they are here. It is where a line crosses the x-axis would be my x-intercepts. So my x-intercepts there would be the point -1, 0, and the point 4, 0. My y-intercept, just like when we were graphing equations, the y-intercept is where a line crosses the y-axis. And that'll just be helpful to us because whenever the x value is 0, I can find the y-intercept pretty easily, just like when we graph lines. So in this case, the y-intercept is the point 0, -4. And if you look at your equation, when I plug in 0 for x, I would end up with -4 as my y value. The vertex is the spot where the graph starts to change directions. Okay, so it's, in this case, it's going down, and then it turns around and it starts to go up. It's also, in this case, this one happens to be my minimum value. So my vertex here is the minimum value of my graph. And the vertex, if I had to approximate it, we'll do it exactly in a minute, but if I had to approximate, it looks like about 1.5, -6.3, let's say. So they're not always going to be pretty, okay? And then we've got this thing called the axis of symmetry. And my axis of symmetry is a line, it's going to be a vertical line that goes right through the vertex. The nice thing about the axis of symmetry is if I have one point, like let's just say I knew that there was a point here, if I go the same distance across, I know there's got to be a point on the other side. So I'm assuming art majors, you guys know what symmetry means, and parabolas are symmetric. So the axis of symmetry, which goes right through the vertex, is very helpful when I'm going to graph. Another example here, my y-intercept I can find out very easily by plugging in 0. So if my y-intercept is here, I just go the same distance across and I can approximate where another point is without actually having to do the math. Okay? Alright, so let's get started and I will show you how to do these. First, some notes. You should have your notes with you, by the way. I think that I used the examples that I gave you in the notes page, so you might want to pause this at any time to fill in your notes. I am going to go fast just because of recording time, but you can pause it and rewind it as many times as you want. So, properties of a quadratic function. How do you know if a function is quadratic? And quadratic, if you think pictorially, it's going to be a parabola. So, how do I know? I should know by the x squared, and you guys should already know that. And just by looking at an equation, I can tell a lot about it. When we did lines, you can tell what the slope is, you can tell whether it's going to go up or down, you can tell what the y-intercept is, all from looking at an equation. And we can do the same thing if it's a quadratic. So the number in front of your x squared, it's not always the first term, it should be, but it's not always. The number in front of your x squared tells me whether my parabola is going to open up or it's going to open down. So in this one, it's a +1, so it's going to open up. If it was a negative number, it would open down. The x squared the exponent there tells me it's going to be a parabola. If there was no exponent, then it would be a line. And just like in a line, that constant number at the end is going to be my y-intercept. Because if I plugged in 0, all the other terms would cancel out. So again, a lot like when we graphed lines, the coefficient of my x squared tells me whether it opens up or down, just like a line, if the slope is positive or negative. My exponent tells me if it's a line or a parabola, and then that constant number by itself tells me what my y-intercept is without really having to do any work. Okay, the vertex. I showed you in the last slide that the vertex is where your graph changes direction. So it's either going to be the maximum point of your parabola or it's going to be the minimum point of your parabola. So it's helpful in that sense, and it's also the axis of symmetry goes through it so that it makes it easy to get more points. Okay? So you will be asked sometime how is the vertex helpful in graphing it? Number one, gives me the maximum point. The axis of symmetry goes through it also, so I can find more points that would be symmetrical. And here is the big thing. So how do I find the vertex? There was a formula to be able to find that one point, the vertex. When I gave you nice and pretty parabolas to graph, like was on your midterm, it was usually pretty easy to find the vertex right away when you start listing your points. But now they're not going to be so easy. So we do have a formula to find your vertex. First of all, we need to find the x value of my vertex. And here's the formula right here. You need to make sure that this is on your notes somewhere that you can find it, because I won't give it to you on a test or quiz. So the x value of the vertex is equal to negative b divided by 2a. Now I said negative b, think of it as the opposite of b. And remember, b is the coefficient of the x term. A is the coefficient of the x squared term. Okay? So I'll show you how to do this problem in the next slide. So that is a very important formula there. That finds the x value of just the vertex. And then once I know the x value, just like you were making a table of values, we would just plug in the x value into the original equation, and then we would know what the y value is that goes with it. So now you would have your vertex. The y-intercept, we talked about that. You could just look at the equation really and tell what the y-intercept is because it's the constant number, or you could substitute 0 in for x because wherever it crosses the y-axis, the x value is always at 0. And now the x-intercepts, some of you didn't do so hot on this on the quiz, although some of you did, but how do I find the x-intercepts? That is when my y value is 0, and so I'm either going to factor and solve my equation for x, or I'm going to use the quadratic formula to solve for x. So I would let the y value be 0, and then you've got a quadratic equation equal to 0, which is just like the last chapter that we did. So sometimes we can factor it, and if we can, that's the quick and easy way, but we can always use the quadratic formula. Okay? So x-intercepts, quadratic formula, or factor. Y-intercept, I just look at the equation or plug in 0. And the vertex, we've got to use that special formula to get the x value, and then once I know that, I just plug it in to find the y value. I'm sure that you need to pause this to write notes down, but I am going to continue here. Okay, so here is the equation that was on the first page. First of all, I know that it opens up, not because I had the picture on the first page, but I know that it opens up because the number here is a 1. And 1 is positive. So I know this is going to open up. And since it opens up, I'm going to have a minimum point. Okay? My vertex, to find my vertex, I'm going to use that formula. And my formula is x equals the opposite of b. Well, b is negative 3, so I'm going to say it's positive 3, divided by 2 times 1. Remember, there's really a 1 here, even though it's not written. So 2 times 1 is 2. So my x value is 3/2. And I'm just going to make that 1.5, but it really doesn't matter. Okay, so I've got my x value. That's 1.5. To get the y value, I'm going to plug it in. So to get my y value, I'm going to do 1.5 squared minus 3 times 1.5 minus 4. Lets me get my calculator here. So plugging in 1.5 would end up giving me negative 6.25. Okay? And you should be using your calculator to make sure you can get these same answers. So 1.5 and negative 6.25 would be about right here. So there's my vertex, and I know that it opens up, so I kind of have an idea right now what it's going to look like. The axis of symmetry is always an equation. It's always x equals whatever the x value is in my line. So in this case, my x value, or sorry, in my point, my vertex. My x value in my vertex is 1.5, so I've got this axis of symmetry. You don't have to draw this line, but I think it can be helpful. So my axis of symmetry goes through my vertex, and it's always an equation that starts out x equals whatever the x value is. The y-intercept, looking at my equation, the x value is 0, my y-intercept is negative 4. So I know that there is a point right here. And you know, I can use that. If I look at my axis of symmetry, that is 1.5 spaces away from the axis of symmetry. So if I go 1.5 spaces away, I know I've got another point right there without doing any math. All right, my x-intercepts. Now I'm going to have to do some math to get my x-intercepts. Knowing something a little bit about this one can be factored. And so if I do a really quick generic rectangle, first term, first box, last term, last box, and then my diamond problem here, I'd have negative 4x squared and negative 3x. And my two numbers where I multiply to get negative 4 and add to get negative 3 would be negative 4 and 1. Greatest common factor of my top row is x. X times x is x squared. X times negative 4 is negative 4x. And x times 1 is 1x. So factoring it, I get x minus 4 times x plus 1. It was an equation, and I'm going to let my y value be 0 because that's where it's going to cross my x-axis. And so my two answers for x would be positive 4 and negative 1. So my x-intercepts would be 4 and the y value is 0, negative 1 and the y value is also 0. So 4, 0, negative 1, 0. So right now I have a pretty good idea of what my graph looks like. It's a parabola. I know it's a curve. It's not a V. So I can kind of come down here and I'm done. So I would like to see at least 5 points when you graph a parabola, and we do have 5 points. If I wanted a better idea of what it would look like, maybe I would plug in 5. So if I plug in 5, do the math, let's see, I would get 5 squared minus, so that's 25, minus 15 would be 10, 10 minus 4 is 6. So if I just did that really quick, when I plug in 5 for my x value, I'm going to get 6. And hey, I was pretty good there. And again, using my axis of symmetry, 1, 2, 3.5 kind of points away. So I'm going to go 1, 2, 3.5 points away, and there would be the other point. Okay? So there's 7 points really quick. I am going to stop this one because I'm not sure if it will fit on YouTube, and you'll have to pick up part 2 then.